So today's topic here, human factors and operator training simulation. My name is Casey Perry. I have worked with P&M now for about 2.5 years. The whole time I've been part of the training department there and leading a team of trainers that I have, which I have 2 different simulator instructors, and then I also am in charge of the apprenticeship program that goes along with our training goals. So before I came to P&M, I was with I basically served 20 years in the United States Navy, and while I was in there as a nuclear operator, mechanical nuclear operator, and I operated for about 5 years a nuclear plant simulator as well, basically learning the principles and all that behind the training on how to use those fundamentals in your simulator to make it most effective. All right, so a little bit about San Juan Generating Station. San Juan Generating Station is a part of the Public Service Company in Mexico. Basically, we serve about 2 million customers within the Southwest, both in New Mexico, Arizona, and we are a mine mouth operating plant, which basically means the plant is right at the coal mine site, so it minimizes transportation of cost of bringing coal in like a lot of other plants have. We have 4 operating units right now. Basically, Unit 1 and 2 are sister units, 3 and 4 are sister units, and I have a simulator that effectively emulates each one of those twins. And we have a total capacity of about 1,800 megawatts. So we had 8 owners. P&M owns about 46% of our company. And I currently have a labor force of about 260 people at San Juan Generating Station. And about 50% of those are apprentices. So it really demonstrates the need for quick training because we have so many apprentices because our senior workforce is of retirement age for about 45% of our workforce is. So it's important to quickly get those apprentices up to date so that and ready to take over for that age of workforce. So I'm going to kind of go over the general makeup of our training program so you can see how we utilize the simulators within that. So we use computer-based training, and that goes back to the apprentice level. And it basically drives basic concepts of systems, how systems work. And then we reinforce that with instructor-led training, which narrows that down to plant-specific topics so that we can reinforce those basic concepts learned in the computer-based trainer, or CBTs. Then we have basically go out in the field and train the operators in the field to make sure that they can accurately perform the functions out in the field, so they get the basic background of operating outside of the control room. And then once they're ready, then we'll bring them in for simulator training. And for a typical operator, it's about a year and a half worth of simulator training to get them ready for control board operations. And in there we teach basic DCS controls, since it's effectively sometimes the first time that they actually operate with the DCS. And we're able to do non-normal operations because with the plant we can't effectively shut it down and start it up in order to perform training. So that's where the simulator is really fundamental in coming in. So we can do so many more training features and put the plant in different initial conditions so that it really challenges those simulator trainees so that we can make sure that they know how to operate the plant during those abnormal conditions. So here's a quick graphic of our training program. So once we get a new apprentice in, basically they go through 3 one-year phases, and that is all geared to learning the operations outside in the field. So then they'll become basically journeyman operators, And then once a position opens up for a control board position, then we'll bring them in and do 3 6-month phases of simulator training and on-the-job training on the control board itself. Once that's complete, then there'll be generation board operators. So overall, it takes about 4.5 years to start this training process and to go through completion. And this is a recent change on how we utilized our simulator in this. Because before we had a 4-year apprenticeship program, this is about 2 years ago, where we would go through, in that final year was their 1 year of simulator training. We changed that because if there wasn't a board operator position open, then we would just send that now journeyman out in the field, and they would forget those key skills that they learned on the simulator. And so then when a job opened up, maybe 5 years later, we'd have to come in and train them again. So to make the more effective use of our training time, then so we developed that journeyman and training phase where we isolate the control board operation of the simulator into that. So really the 6 key reasons why to have simulators and the benefits of simulators. One, so it's plant specific. We use it for initial and recurring training. We train plant operators, but we also train shift supervisors. A lot of the supervisors that we hire don't necessarily come through the journeyman ranks at our plant, so it's important to train them so they can properly supervise their crews. So we bring them in and teach them plant operations as well. And then also for engineers, if they're looking at making a change to the DCS and want to understand how the controls work, then they usually ask us, and we'll go through particular system controls with the engineers so that they can visually see it, because on paper it makes more sense sometimes. So the basic reasons to have simulators: increase plant systems knowledge, function and interaction with other systems. Sometimes that's hard to teach when you're in a classroom, in the classroom phase, trying to teach how systems work together. And that's the key thing about simulation, especially when they're dynamic, high-fidelity simulators. You see one change parameter, one particular component, on how it affects 3 different systems. And that's really the knowledge and understanding that we're trying to get across to our trainees. Also, gain operator experience, confidence, and accuracy in normal and abnormal operations. So a lot of times, it's not the best time to learn how to do something whenever you see it for the first time on the real plant. So we bring operators in order to really challenge them for different, maybe a malfunction that we not typically see, but that we could have a potential of seeing. Bringing them and running through those scenarios so that we can make sure that they're prepared. Provide practice, following specific operating procedures. So these are the routine operations that they may not normally, that they can see for practice so that they can gain experience, and for the startups and shutdowns, like I said, that we only do about once a year. So it's very important there. Enhanced understanding of the digital distributed control system. That's key for some of these trainees. The first time that they're seeing the DCS and how to interact with it, and so it's fundamental there. Improve understanding of general plant theory and concepts. It just reinforces what we try to train on in the classrooms to build up, to reinforce that training that they get in the computer-based and the instructor-led training phases, and demonstrate the recovery from abnormal conditions and malfunctions. So what we typically see this is a real challenge for our junior people or trainees when they first start trying to understand, when it goes back to that integrated plant operations, when you have a malfunction and what you have to do to recover. Because sometimes you don't have a whole long time before you can really multiply the factor of which the malfunctioning will affect the plant. So that's a key part of that. So, and then there's some advantages to basically us trainers on using the simulator is a training tool. One, it allows us to set a standard for the training. We can run the same scenario on multiple people and grade them all equally. And that's important for us. We have a unionized workforce, and so we want to make sure that our training is consistent, and the simulators allow us to do that, but it also pinpoints what training that we want to get, or basically run the trainee through. So if there's a particular malfunction, particular scenario, then we can have all of them run through the same one and evaluate the trainees against each other if we need to. If there is a job opening and we want to evaluate which is the best prospect for that job, then we can use that for that. Also, we do this several times when there is an issue at the plant, and we go through basically critique what happened and why it happened and what we can do to prevent it in the future. Go through a root cause analysis for corrective actions. A lot of those actions are to develop that scenario within the simulator and bring our operators and our supervisors through to make sure that they understand how to handle that situation in the future, so that we can either prevent it or minimize minimize how great that the scenario was. An example of this recently happened where through this winter we had some lines freeze on a flow transmitter in our feed system, and at the time our simulator wouldn't model that particular, or that particular component wasn't modeled within our model, so we had to work with SimSci Score, which has developed our simulators, and so they were able to put that functionality in order to replicate that scenario that we experienced at the plant, and then it allowed us to go through and complete the training for the operators and supervisors. It's really beneficial to us, the support that we receive from Inventus and SimSci Score to do those type of changes for us. So we have several basic functions that we can use: initial conditions, malfunctions, backtrack, so we can practice one particular item. If something's not going well, practice over and over. So new operator training can be done more quickly, in which I'll show some graphics that show that, and allows for testing of control changes prior to plant DCS implementation. So this is actually an item that we're looking forward in the near future that's going to be important. So a couple of statistics here. About 42% of operator error results in about 42% of the unscheduled plant shutdowns industry-wide. So it's a pretty major factor. So better trained operators and minimizing that error will definitely change your profits in the industry. And as far as safety, about 26% of all accidents occur due to operator error. So this is one thing that kind of fundamentally is the safe operation of the different systems is definitely something that we get across with our trainees using our simulator. And then also, if you have a major incident at your plant, it's costed some plants up to $80 million in order to repair that. Some of these could be major turbine damage because they're not operating maybe a support system for the turbine as directed. So all these can be discussed and trained on within the simulator. All right, so the different ways of learning and to knowledge retention. So if you just do lecture, the studies show that only about 5% retain just from lecture, about 10% retain from reading. Then when you go to computer-based training, you get a little bit more training. But when it comes by the simulator, you get about 75% retention, especially when it's reinforced by if you are having problems with whether you have a pump trip or a valve malfunction, you can go back and practice it over and over again to really establish those skills in order to handle that whenever it would possibly occur in the actual plant. So this is something that we've definitely seen through that 1.5 years, or the 3 6-month phases that our trainees go through. A portion of that is dedicated to strict simulator training time. And we've noticed their performance that greatly improves when they're able to practice simulation. And so you more quickly become proficient when you're operating a simulator than just on-the-job training, because on-the-job training doesn't give you the plant scenarios that are really critical for learning that particular job as a control board operator. All right, a little bit about our simulators at San Juan Generating Station. I currently have 3. I have one. Each one is designed because of the different equipment that we have for each one. Our environmental simulator, we just completed an upgrade on, and I got some lessons learned that we learned from doing that upgrade. And earlier last year, we completed an upgrade on our Unit 2 simulator, all done by SimSci Core out in Carlsbad, and then Unit 4 simulator as well. So this is a picture of our environmental simulator right now. You can see in the background there, we have 12 screens for each one of our simulators, and that replicates what's actually in the control room. We typically train one person at a time, but we can bring 2 operators in for training. And then in the foreground is where our instructor station is, which is, we found it more effective if we're able to answer questions while we do simulation, and so we do have an instructor during that time. So I'd like to show you there's many different training value that you can get out of training with a simulator, and this is one of them. This is a key one for us. Basically, I'm going to be talking about a training performance measure, how we evaluate performance on the simulator. So this is a typical DCS screen right here, and one thing that we can do if we want to basically evaluate, maybe it's a load ramp from 200 to 300 megawatts, and we want to track how the trainee can maintain steam pressure, steam temperature. We can pick various parameters that we want to focus in on that are the highest priority, and then we can attach them to this is an example of a TPM, we call it, training performance measure. And over in the kind of the grayed out area there is all the parameters that we picked for this training scenario. And we can set high and low limits for what we value that the trainee should be able to keep those parameters within. And then as we run the simulation, it continues to calculate kind of a grade point average for each one of those simulators based on the time outside of the high and low limit and the amount that they're outside of the high and low limit. And it gives us, basically at the end of the training scenario, it gives us an overall score, in this particular case, a 96% for this evolution. And this is key for basically maintaining good records of your training. And for us, we've had insurance companies come in and make sure that we've done proper training on our turbines and our boilers because they want to see how our training program is used and works effectively, and this is a great way that we can show that. Okay, so the next part here, I just want to cover some lessons learned that we recently did 2 upgrades. And one is about our 2 simulators that we upgraded, our high-fidelity simulators. And it's important to maintain them up to date. We have typically gone through about every 2 or 3 years doing a large upgrade. But more consistent upgrades is what we're finding more valuable. And in order to do that in the future, we're going through virtualizing our hardware in order to have basically our simulator hardware with our actual DCS hardware together, so when the controls are changed in one, the controls can be changed in the other more efficiently. and so that's a benefit. Oftentimes we just verified the parameters track with the actual plant. It's critical that you have actual good plant data to provide in order to make it easier for that. And we also found it easier we went through a model review before the pre-factory acceptance test, and that really helped us out with that. And it's also important that when you're evaluating software updates, hardware updates are likely necessary. P&M chose for our first simulator upgrade not to update the hardware, and it had some complications with running the simulator long term that we're able to address now with this virtualization that we're about ready to go through. So it's key to make sure that the software and hardware are basically compatible for effective simulation. All right. And then another key aspect with simulator training is make sure the environment replicates the control room. So it brings up alarms. So evaluate alarm management, communications, field operations, surroundings are all there. And all this is going through trying to show that the trainee that we are really taking the simulator to the max, trying to get it to replicate the plant. So this screen here is to show some of the challenges that my company has with this, is we're likely to, here in the near future, retire 2 of our 4 plants. And so there's going to be a lot of training needs that the simulator is going to be critical on for cross-training people to basically move from one plant to the other, and also possibly reducing our workforce by about 80 people because of those changes. So there's going to be a lot of cross-training going on, and the simulator for us is going to be critical in the success of that. So in summary, basically, I want to just get across, how we use a simulator, the value it is for us, the important relationship that we have with SimSci Escor and Inventus in order to maintain them up to date, and which is really critical for us, and some of the training features, and a little bit of lessons learned about our past 2 different upgrades. So thank you for everybody's attention.